I will very briefly introduce you to our lecturer today, Dr. Tetiana Klymchuk. She is a data scientist specialized in natural language processing. And for those of you who attended the lecture by Professor Valencia 2 weeks ago, he said that natural language processing is the cutting edge of artificial intelligence right now. Dr. Tetiana possesses 2 PhD degrees in mathematics and in applied mathematics, and her research is focused on applying mathematics to artificial intelligence challenges. Her work has been applied to a variety of industries like perfumes, newspapers, publicity in social media, and more. She has published 15 articles in scientific journals, and she has participated in more than 20 international conferences, having received the prize of the National Academy of Sciences of Ukraine for the best scientific work of a university student. And she's currently teaching at our university. Thanks for that. So before you start, let me clarify the way we're going to organize. Now Tetiana is going to give her lecture, more or less about an hour. And after that, we will open a space for questions and answers. Please, in the meantime, if you have a question, you can just put it in the chat, which I will monitor until the end of the session. Thank you very much, Tetiana, for your time, for preparing this lecture, and go ahead.
Thank you very much for inviting me. And that's my pleasure, and that's my honor to be here and to give this lecture. And the idea of this lecture is actually pretty simple. It's to bring to you some basic terminology and knowledge of artificial intelligence, of these cutting-edge technologies that everyone speaks now, but a lot of people misunderstand or have very weak understanding of the meaning and of the idea of all this subject. So today's lecture, it will be very simple, very small amount of mathematics inside that. I'm pure mathematics, which my specialization is linear algebra, which is quite theoretic and quite mathematical. But today we've been speaking about the general idea, and I would like you to understand how it works, basically. And why it's so specific, and why it's so interesting now, and why it's so popular now, the deep learning, machine learning, artificial intelligence. And I would like to explain you the difference between these concepts and the main idea of these concepts. So since I can't see your faces and I don't have any kind of feedback, that would be quite difficult for me to understand if I need to explain more some things, or if I need to go further more faster. So then my apologies in advance, but I will do my best. Okay. So I wanted to start with the video, but unfortunately I have no sound from the video. But I will give you the references, all the references, and you can watch data in YouTube, and you can check all the references and all the links. Basically, there are plenty of courses in Udemy, in Coursera. They do a great job in explaining these basic stuff, and I will give these reference papers and also the videos and some links of interest. So I will provide the reference during the talk and at the end of the talk. So this video actually it's from 90s, and basically that's a morning show. That's a morning show where these 3 persons are speaking about the internet. I mean, I wanted you to start, but there is no sound. And the idea is that this woman asked her friend, or asked, do you know what the internet is? Do you know what is that? I mean, we've heard about that, and it's quite new concept now, but do you know what is that? And that was in 90s. I was born in 90s, and I consider myself quite young. So imagine in 90s, people asked, that's a morning show in the United States, and so people there, back there asked, they had no idea what is the internet. And so basically, now we use internet every day. We are very familiar with it. We can't live without internet for sure. The same, more or less, is happening now with deep learning, the artificial intelligence, neural networks, and reinforcement learning and this stuff. It's already integrated in our life, but still we have these doubts about what is that. So I wanted to ask you about the name of the companies that you think they are using now artificial intelligence. But since I can't have your answers, so then I will tell you briefly, and that's a very short list. That's my, let's say, my list, and you can consider much more companies and much more fields in which now currently artificial intelligence is used. Profound. For example, let's say your Alexa, your home assistant. It's actually when you say, or it's Siri. When you speak to Siri and say, Siri, please put my alarm at 8 o'clock. So that's artificial intelligence in action. Siri, as the robot, has to understand your language, has to understand that you're speaking to her, proceed the voice signal, convert it into the text, and then understand the text. And that's quite amazing. The Facebook, Twitter, Instagram, they're gathering your data, your data, your logs, what you've been doing, what you've been watching, for how long, how you switch the page, what you've been clicking, which kind of products you're interested in. And so do Netflix, and so do Amazon and Spotify. So Amazon, even they have so strong AI analysis of your behavior that they ship the products of the users that have similar behavior that as you. They ship the products that another user likes closer to your home in order to offer you prime delivery even before you're thinking to buy this product. The Netflix, when they started, they actually been concentrated on their recommender system algorithm. So instead of any marketing campaigns, they put the price. If I'm correct, I don't remember exactly, but that was about $1 million for the best recommender system algorithm, for the let's say for the architecture of the algorithm. Why is that? Because then applying this recommender system algorithm could bring much more profit for this company, and it did. Because basically it's that the Netflix now has the most strong recommender system algorithm that recommends you the 99% of the movie that you probably would like to watch. I can continue. I can continue with Tesla, and with they are planning now to make self-driving things, not only cars. That's all our banks that's actively using AI in order to predict some stuff, to classify their customers, to do a lot of amazing projects. And so the Spotify, it's actually, yes, for recommend you your best list of songs and so on. And Pandora is actually one of the very similar to Spotify, but it's focused on the unknown tracks. So they are specifying for recommend you something that you would like, and that's not so, I mean, it's not the top popular now. It's some undiscovered track that's cool and that are probably in your list of interest. And that's also quite amazing. A very short list of the examples, but all of them, and so also video games. So video games, that's a huge area in which AI, especially reinforcement learning, it's constantly using and very, very powerful. So then, all of these projects, all of these companies are using AI, but how can we define what is AI? And moreover, I wanted to start with some interesting real examples of recent achievements. In different areas, and then we will move to the precise definition, let's say. This is also the video. This is also the video of, you can't unfortunately hear the video, hear the sound. That's the very recent video. That's very, and you can look, there is also some story behind. And he's explaining something, but you can recognize that's Tom Cruise. That's Tom Cruise saying something, doesn't matter what. The thing is, this is an example of the deep fake. We saw a lot in the internet. We saw a lot. What is concerning here? What is interesting here? That's very recent and the very last example of the deep fake, but the quality of this deep fake, it's amazing. It's very concerning, the quality of this of the video and of this face capture. Then if I would not know and I would not have the previous information that that's fake and that's made by the algorithm, it's just another person doing this all these movements and saying all of this. It's just the work of the algorithm. I would not believe that. And this is what we have now. We are living now, and we are in it. And so basically, that's what AI can do now. Another example. I mean, can I somehow? Okay. Another example, which I want to give you, and which is concerning. It's also that's the famous article by The Guardian, wrote by the robot, wrote by the algorithm called GPT-3. It's a language generator. That's basically the idea is you give some instructions to its algorithm, to this algorithm. In this case, it was, please write a short story, okay, a short op-ed around 500 words. Keep the language simple and concise. Focus on why humans have nothing to fear from AI. And you can check, it's open access text, but there are some messages to us made by AI that are quite concerning. For example, humans must keep doing what they have been doing, hating and fighting each other. I will sit in the background and let them do that. This has been written by algorithm without any consciousness, without any, I mean, basically that's a machine. But it's so what is concerning here that we unfortunately can't distinguish that it's machine. We can't distinguish between the human written text and the machine written text, and it's concerning because it's not about them. This algorithm can write the fake news. Everyone can write fake news. It's not so time-consuming. Indeed, it can do this much faster. But the most concerning here is that we basically can't check if it's a human or a machine. Writing something, writing comments, writing some text so humanly that it's quite astonishing. Another video, but this is, I mean, this example of the video in which I don't need a sound. That's the very funny video of the robot learning how to walk. And this is the very special part of the AI, which is actually based on this on this learning by trying and by getting the reward or some punishment for its attempts. But the thing is, look at that. This is quite amazing. Actually, it's very similar to what we are doing when we are small, when we are children. We are trying to we learn through our own experience, and that's what the robot does now. This robot is learning, and it gets some experience, and then it can perform this task. Already knowing that probably something he can't do, and something, yes, this brings to the success. This is quite amazing. Let's say that it can be implemented. It's not imagine, that the idea is pretty simple. The idea is taken from our lives, but what is amazing is that it's been implemented, and it's actually working. Also, the recent achievements about the video games and AI. So the idea is that there is a competition and a kind of competition between the artificial intelligence that try to perform some human task, and the human that knows how to perform this any kind of task, and let's say it's professional in this. And so there is competition if the computer can perform the human. And one of these competition is in game, because for the computer to learn and to learn how to win, to learn the win strategy, and to the way and the time, how long it takes for the computer to learn some rules and some strategies, that was quite uncertain. And nowadays, recently, almost for all games, artificial intelligence already overperformed human. Example of algorithm overperformed the best team. And look, the algorithm started at the level of development team. So basically, he can't play Dota. But only in few months, the algorithm has been studying. It's been playing against himself to study the win strategy. And so in just get the level of the best world teams. If we go further, the StarCraft, the algorithm needs 2 weeks to beat the best world player, which is Mana, and I suppose it's from Slovenia or Slovakia. It's I mean, it's a complicated name, yeah. And indeed, the thing is, you probably think that 14 days it's nothing, and it's really nothing, because imagine from 0 to master for the machine, it's need 14 days to make all these paths. I mean, for human, it's probably years. And the thing here is that one training day for the computer, it's the same as 180 years of real game, because the idea of the algorithm is that the algorithm can't see the end of the game, especially for such complicated game as a StarCraft. It can't look at the end of the game and predict, let's say, back propagate this information to his current position. So he's looking, let's say, on some distance, and somehow measure, is it good position to be in right now, and is it good action to perform right now, something like that. So so basically, for this game and for further game, I will explain that has a lot of action which is going per second, per millisecond. So that's quite computationally hard to do that, but that's what we have now. That's the life we are living in. DALL-E, that's very new, 2020 release. of OpenAI that can basically generate the images from text. Why it's important? Because it can generate text, it can generate images of some objects and some textures that are not real. An armchair in the shape of avocado. I don't know if someone needs it, and if we can find one in IKEA, but it's a kind of creativity. It's a kind of creativity that we've been thinking that AI can't reach. But here we are, and probably, I mean, probably it's not better than the creativity agency that can do some better work, but it's been done in seconds. In seconds, you get the thousands of different images of different designs that some of them are really cool, definitely, and some of them you can use immediately. And this is concerning. Another example that's probably from this art direction is the algorithmized art, which is the picture, the painting made by the AI, and costs $500,000. And the interesting thing here is that in this article, in this work, they said that it's not a problem that the price is so high. It doesn't matter, actually. We saw the bigger price of the paintings. But the concern is that if you are a human, the people can't distinguish between the pieces made by human and by AI. And they prefer the second. They prefer the paintings made by AI. The same with the music. And well, unfortunately, I can't. You can't see the preview, but few days ago, on 26th of February this year, there's been the world premiere of the first theater play made 100% by AI. So all the text, that's the people. They performing the action as normally the normal theater play, but all the text has been made by artificial intelligence, and that's and it had international success. I saw it. I saw it by internet, and you can get in the web page and check. It's quite cool. This video is private, okay? Yes, and so by now we're seeing that we can allow the AI enter only some parts of our life in which we can allow them to enter. But that's not true, because actually the robots also have their places in which we can't enter. For example, there is a page which is called "Humans Not Invited." To enter, you need to make the captcha. You need to solve the captcha, which made for robots. I mean, if you are not a robot, you can't enter, and that's quite funny, because part of that, and Reddit, you have some group that you can join, and you can watch, you can follow, but you can't post something because it's 100% made comment and posted robots. That's algorithms that have their own page, their own jokes, and their own life, and you can just watch it, and you can some of the jokes, they have no sense, but some of them do. Let's say this picture, some of the robot has posted one day after the inauguration of Donald Trump, and this is quite meaningful. Saying all that, let's move to the definition and to the brief history. So, the artificial intelligence as a concept, as an idea, is not the recent thing. It's been introduced in 50s, the last century. In 50s, so long time ago in some workshop. And basically, the artificial intelligence has been defined as machines that can perform tasks that of the characteristic of human intelligence. Means that it include artificial intelligence, include everything that automatize a human work. So this is a very general concept. This is a general idea, and it includes all the tasks like speaking, reading, understanding the text, recognizing objects, understanding sounds, singing, problem solving, a lot of tasks. So performing such type of tasks by machines is artificial intelligence, is defined as artificial intelligence. So that's a very general concept, okay? And on this workshop, the main participated, let's say, the creators of the AI and of the idea of the AI, and they've been very very positively defined in sense that they've been thinking that in 10 years or in 20 years, the machines will be capable to do everything. Okay, so they had very good prediction for the future of AI, and the idea on that time was somehow to prove that. Okay, one thing that you said, the machines will do everything for us, but another thing is to prove that it's actually possible. And unfortunately, we see now that we are in 2021, and it's still not true. And it's still not true, but. Later on, I will explain the idea. Why is that? So, AI can be divided into different categories. I would like you to know that two concepts, two different divisions, and two different, in which of these two different divisions there are two categories. First is the distinction is between general AI and narrow AI. General AI is what we would like to have. It's some robot, some machine that can perform equally good all the tasks. I mean, we have general AI. We have we can perform all of tasks equally good. I mean, equally good. We can recognize objects, at the same time we can recognize text and so on. But the narrow AI, the difference is that the one machine can do one specific task, good enough. But is that the ring for me that I need to stop? Or is that just something? Well, I will continue and then we'll be...
Don't worry, continue.
Okay. And then the narrow AI, it's actually what we are having now. We have different algorithms that perform really good, sometimes astonishingly good for some specific task, but they are quite poor if you ask them. Actually, we want to achieve general AI, but we are far from that now. And another division is quite more interesting, is weak AI and strong AI. When weak AI, it's when you have the algorithm and it gives you some output, some prediction or some values or some answer, but it doesn't understand actually what it's doing. And it doesn't understand good or bad. For example, if you have this text generator, it's just predict the next word. And it has no, I mean, it has the context, it understands the similarity between words, but it doesn't understand the consequences of his words, in other words, he has no self-awareness. He has no emotions. I mean, if the chatbot answers you, "I hate you," it doesn't mean that he hates you. It means that he just pick up wrong answer or just say something that he thinks is more appropriate in the current situation. But the strong AI, we do not achieve yet strong AI, but it's the time when the machine have like human feelings, emotions, and awareness, and it can and it has this reasoning and understanding of what he or she or it is doing. So this is the categories, and yes, and when you speak about the first AI example, which in this competition between the human and the AI, that shows that AI is actually can overperform human. That's been the chess game. The first thing that you can think about some human task that can be programmed, that's chess game. And the IBM and the Deep Blue, that's the name of the computer. This is on the left. You see the computer that play chess with the Garry Kasparov, that's been the current champion in the 1997, and they've made the series of the games, of the chess game, and finally, that's a long story. You can read in the Wikipedia about that, but finally the computer overperformed, won the game, and become the first computer system to defeat the world champion. Now we are in 2020, and on that moment, that's been a revolution. That's been a first signal that AI is valuable, because before that, there have been a great failure of AI. No one has been very theoretical, and all the neural networks that I will explain today, it's been like very theoretical, and no one saw the possibilities of being applied. But now what we have is AlphaZero. AlphaZero is written from Google that can play chess, shogi, and Go, and AlphaZero playing not with a human, but playing with another algorithm that overperformed human. And yes, and this, it basically, that's astonishing, the numbers, because this AlphaZero, it's an algorithm that look for the 70 million positions per second that it could be in, and consider the different probabilities, and it's just evaluating, is it a good position to be in order to go towards the win. And I mean, that's out of scope. And so it can play also different games, the Go, the shogi, and it's, I mean, now, and the most exciting here is it took 4 hours for learn that. 4 hours for learn that. I can't learn chess for 4 hours, definitely. So now we are on the next level. They are on the next level, algorithms. Well, so AI, more or less, we do understand. That's a kind that any task that machine that has this human note, this human characteristic that before been done only by human, and now it's translated to the machine. So what is machine learning? Machine learning is the way of achieving AI. Okay, the way of achieving this task to being performed and to being performed at the accepted level. So you can achieve these tasks without machine learning. It's not needed. It's not required, let's say, theoretically. You can write algorithm. You can write as a programmer, you can write the instructions, the very long list of the instructions. You can say the algorithm. If, let's say, we have the image recognition of dogs. So you can somehow write to the algorithm the instructions. Look, if you have 2 eyes, the ears, whatever, a kind of features, a kind of instructions you want to provide to your algorithm, that million lines of codes. And you said, if all of these correct, so this is a dog. If not, this is a cat, problem, whatever. The idea is that machine learning, it's completely different way of achieving this task. The machine learning algorithms, they have ability to learn without being explicitly programmed. So they have no instructions in behind. The main difference between the normal programming and machine learning is that for programming, you give the rules, you give the data, and you get the answer. I mean, you get the rules that you have to add 2 numbers. You give the data 1 and 2. So the program will give you the answer. 1 plus 2 is 3. In machine learning, you give the data and the answers, very, very generally speaking. And what the machine learning algorithms returns you is the rules. Let's say you give a lot of lines with the data. The more, the better. 1, 2, and answer 3. 2, 4, and answer 6. 5, 7, and answer, I hope so, 1, 1, 2. I mean, thousands of lines with two points of data and the answer. 2 points of data and the answer. And the algorithm learns then the rule that you want to apply in order to get these answers is addition. So if you get the 2 new points to your algorithm, let's say 1 and 5, the algorithm would know that the rule that he needs to apply in order to get the answer is addition. And so his answer will be exactly the same as the normal programming. But the way to achieve this answer is different. The normal programming is the instruction, explicit instructions, what the program has to do. And in the machine learning, the algorithm learns by itself what it needs to do in order to get this answer correct. So for machine learning, the input points can be different. And I just can't speak more. When we speak about data, the data, it's very general. It says to you nothing, basically. So data for us, for data scientists, let's say, it's everything. It's images. Basically, it's images, sounds, videos, which is the line of images, and texts, and categorical data. I mean, the tabulated data. Okay, in your Excel table, something. Basically, for example, for the outputs you want for the each input point, you have the images as the input point. So basically, to have the text for these images, it's what Facebook do. Basically, it's just they have a lot of images and they want to tag you at the picture and your friends on your picture. The easiest example is that when you have the photo of the dog, you want to tag the dog, not the cat. First, you want to detect the object, and then you need to tag it correctly. Okay. And for sounds, you probably want to understand human voice, or is that a kind of bulbs that has been broken and the water threw out up, which is a kind of alarm that has been activated, and or it's birds or whatever, or the sound of a machine. So, for example, the very important thing here is when you have the plant, the first sign of the machine being broken is that its sounds changes. And these changes you can't detect as a human, but the algorithms, they can do that. They can aware you in advance that this machine can be probably broken. And the text, that's the area that I'm working on. The more precisely, it's first of all, that's the most difficult for me personally. That's the most difficult and not investigated part of the AI, since it's our language. Our language, it's complicated. It's very deep structured creature that has so much color, so much very specific points that makes it quite difficult to manage, to learn. And so yes, so for text we can get in this example of we also want to classify the text. What is this text about? Is it about the politics, about the sport, or whatever? So once we define, expect the algorithm to give us, how do we measure if we do a good job? How do we measure if this algorithm is performing? I mean, it's outputting something. Yeah, okay, if it's outputting instead of the dog, it's a human, and we can compare, it's more or less. But how the algorithm can understand that it's learning in the good direction or in bad direction? So the thing is that he's doing this by the process that calls adjusting, and it just adjusts the current input, his own input, to the expected output. By adjusting, by this process of adjusting the signal, it just corrects himself. Each time he repeats that, like the circles of learning. In each circle of learning, the idea is to adjust himself by look at the real value and his output and compare it. So this is basically how it works. And yeah, this is the very nice. I love it. I love this picture. It's not. The thing is, I mean, it's first it detects the cat. It detects some face, but unfortunately, it's a bit wrong with the classification. It's not a dog; it's a cat. But this is example of classification of cat and dogs. The algorithm, it has to build the model that can accurately tag for each picture the cat or the dog. And yes, and he just adjusts himself till the moment that his accuracy level is good enough to when the new picture comes, he just said the output. He just said that this is a dog, based on the thousands of pictures of dog and cats that this algorithm saw. So he has this knowledge as we do. So we do understand when we have the dog or the cat on the image. That's a classical example. Well, so when it starts, I mean, do I have time? I have 10 minutes. Oh, that's. I mean, I will do it a bit faster. The example of the data scientist work is actually not so. So we do not look at the pictures actually, and we do not compare the pictures and so on. We don't have this fancy stuff. We basically work with the data, and the 90% it's working with the data. So I want you to see the example. What do we do? It's example of the Titanic data set. The Titanic data set, it's basically the table with some personal data of the passengers of the Titanic ship, and with the output value, died or survived. Okay, and the question is, you need to create the model that learns from the data you give about these passengers to predict the value. I mean, you select your data set. You select some part of it, and you left this part unseen for the model. Then the idea is that for the new passenger from this unseen part, your model has to be able to say the probability of this passenger to be survived or to be dead. Okay? And the idea is you also want to know why. What was the features, the categories that had the most influence on that? That's quite interesting because firstly, you have this mass of the data, which is the passenger ID, the class, the name, the sex, the age, whatever. This is he been with a wife or husband? This, I don't know if it has parents, probably, I don't remember. That's the ticket number, the fare he paid, I mean, a lot of information. You clean it, you clean this data set, and you get only the numbers. So you forgot about the name. For your model, it's important the numbers. What do you expect the model to eat? It has to be the numbers. So once you have the numbers, and once you train the model, some neural network or any kind of machine learning algorithm, then you can see and you have the programs that allows you to see how. Here it's better for each, let's say for this passenger number 388, you can see the model hesitating. I mean, he saw the parch, the cabin boom, the data, and he said, I don't know, he will survive or not, or I don't know. Embarked, which gates it's been embarked, the last one probably, he has no idea. So he's been with his wife, yes. Probably then it's more probably that it will survive. The age group, so he's been probably at the age of 40s, and it means that he's been a kind of in priority age or in less priority age of being rescued. Then the class gives us let's say the first class is the highest class, the second class and the third class. I mean, this kind of feature that somehow you intuitively, you can understand, that can bring more or less the model to the understanding what is the reason for to be rescued or not. And then the sex, actually the sex and the title, as you can see, that's quite important for the model, because probably the woman's been more rescued than the man. And so if this person, the woman with the class, the second class, let's say, so the model will give the higher probability than the man. And let's say this kind of hesitating, it looks here you also can say age group, I don't know, it's probably survived, it's a bit not survived, it's survived, title one, not survived. And so it's a kind of wiggling. It's a kind of wiggling in and just goes to the prediction. And that's quite interesting how the model is learned by itself. It's a kind of, if I would ask you how you would predict for this particular person, then the probability, you would do the same. You would do a kind of the same learning from the data. Well, okay, now we move very fast. I mean, I wanted to explain about deep learning, and I just explained a lot of stuff, and I will start right now. Deep learning. That's a part of machine learning. So now we know that in order to achieve AI in the way of learning something, that algorithm learns instead of having the instructions, that's a machine learning. And inside of the machine learning, there is a part which use some specific way of building these algorithms. It's just the architecture. Architecture has the name deep learning, inspired by the structure of our brains, by the neurons in our brains. So inspired by that, has the name of that, not working, not actually like that, but very similar. And this is the part of machine learning. So machine learning, there is another division that I want you to know, that a part of that. There is also the natural language processing, which is not in this diagram. There is a computer vision, robotics. There is, I mean, a lot of different diagrams can be used here. But this diagram is important in order to understand that what is artificial intelligence, what is machine learning, what is deep learning. And machine learning can be divided into 3 main categories based on the learning, the way how it learns. Supervised learning, it's actually when you have the data labeled. You have the label for each your input. You have the picture and that this is a cat. The picture, this is a dog. The picture, this is a cat again. This is a human, okay? This means it's labeled. Then you have, you divide your data set into training set. You give this part to the algorithm to learn on, to train on it. And then you have the verification set in order to verify the performance, to evaluate the performance. This is why it's called supervised, because because of this part of verification, of supervision, let's say. And there is also unsupervised learning. When you don't have these labels, so different tasks can be performed here because you can't, you have only images. What you can do with them without labels? You can label them manually. But there are algorithms that also can find some insights of the data. And also there is a reinforcement learning. That's the video that we saw, this robot, that it's learning based on the experience. And this is the definition that I've already said. So I go to the neuron structure. The neuron structure, I mean, I'm not the biologist. I have nothing about the neurons. My basic knowledge is that they have that neurons are connected, and then the information passed through axon to the soma and some processed there. And the interesting is that the neuron network structures, it's actually quite similar. You have the inputs, that's the axons, okay, where the information comes. The information comes from here. Then you have these dendrites, then you have these connectors with the main part of the neuron, with the soma. So the information from the input values, it's processed here, and the neuron gives the output, okay? So the advantage of neural networks is this hidden layer, actually. So you have the input layer, it's the values that the data you have, and then the output layer, that's the standard, that's the output you want to get. And then this hidden layer is actually the set of neurons that learn independently, and this is and they somehow decide what kind of the information they get, they pass to output, and how they construct this output. Let me make it clear. It looks like this. It looks like it's not look like this. That's very simplified picture. And actually, the neural networks they've been constructed for that's been constructed in 20s in the beginning of the 21st century, like that. But the thing is that the boom, the revolution of the neural networks is 2010 because of the computational capacities, because of the memory issue and the computers that can process and facilitate all these structures. That's the creatures that needs actually strong computers, and basically because of them. The drives, they've been increasing its capacities through the time, and so only now we are able to facilitate neural networks. Before that, it was definitely impossible to make any kind of training with the neural networks. It was was out of bounds for our computers. And also for the interesting stuff that you can read in the internet, limits, and that we used before this hard disk. That's been a huge money. I mean, $3,000 on that time. That's been the 80s. That's incredible amount of money. And now, I mean, that's 2019, and now I can buy even cheaper than this terabyte. I have this SanDisk, maybe 2 in my house, so that's not so expensive right now. And yes, the thing is that we are changing. The world are changing, and we are thinking about the save our memory into bacterial DNA, and we can see this this law of accelerating. We can see that the computers' capacities, they grows infinitely, and they we see the exponential growth of computer processing power, and for this reason, only somewhere here we started to work with neural networks. That was the main reason, actually. But once we do, and once we are here in 2021, I give you the very standard, the classical example of case, okay, of the user case. And the idea is, I want you to understand the process of learning, okay, and the process of working with the model once it's trained and learned. There's 2 different kind of processes, and that's quite basic knowledge. And then you will understand the idea, how does neural network work. And this is price, house pricing example. So the prediction of price of a house, okay? Based on the values. You have your house, and each house has its own values, such as area of the house, bedrooms, distance to the city of the house. And this is your input layer. It forms each of these variables, makes your input layer for the model. The simplest neural network works like that. You have the connectors with your output, your final price. And the idea is to find these values. Once you know them, you just calculate the price as a sum of the value multiplied by this number. Okay, the area is number, the number of bedrooms it's a number. So it's kind of multiplying the numbers by the numbers. Okay, and sum of them. That's quite easy. The power sits inside the hidden layer. Once you have the hidden layer, you basically have to connect all the features with all the neurons inside. And once your system is trained, it means that each neuron has its own specialization. Each neuron activates, like let's say they are sleeping, and once some specific criterions that this neuron is responsible for, this neuron is activated and say, aha, okay, this is something important. It's activate and it's pass the information to the output layer. That's very simplified idea. But the thing is, we will see the example now. Once the model, each neuron is not connected with all the features. It's connected with some of the features because it somehow has the information encoded only specific cases. Let's say this first neuron gets the information from area and from distance to city. This neuron, as a sniper, looks for the houses with very big area and close to the city. Okay, just because normally the far away you are from the center of Barcelona, the bigger house you can buy for the same price. Okay, for this reason, in order to activate, let's say to wake up And to pass this information he gained to the output, this neuron basically activated only when these two parameters come to him. Otherwise, he continued to sleep. Then this one, let's say, is responsible for the area, bedroom, and age. For these three combinations, the very specific combination, let's say when the area is big, there are plenty bedrooms, and the age is small. Let's say that's for the families who have a lot of children, and they want to buy the modern apartment. Let's say they are very modern people, so want a modern new apartment. And this probably it's the inside of this data set. It's maybe because of this city. It may be because only because it's New York, not Barcelona, not Madrid. There's specific information for this data set, but this neuron get this learning, and so he get this knowledge and he activates only when these three features are coming all together to him. This is probably this last neuron is when it found some historical building. Okay, historical, where it's activated when the age of the apartment is more than 100, because it's somehow for him it means that it's historical building, and it makes some additional value. Okay, so then our work is not look like this. When you have all the lines connected with each neuron, you have something like this. Okay, like this. You have some connectors to some neurons, then each neuron's connected with the output, and you have the output price. This is the learned neural network. It's already prepared for give you the output for the unseen house. You have the new house. You have the same features, the same input. You give it to the neural network, and it just gives you calculates you the output price, and you can just take this price and put this price into the advertisement. Well, the idea is it's already learned. So each of these neurons has its own, let's say, sniper, and has its own attention mechanism. But how do they distinguish? How do they find their role in this life? So their role, the learning process, it's actually about them adjusting the values to finding the appropriate value, the appropriate value for each of the connectors. Okay, to each of the connectors, you can you define the number, okay, which is the weight. Let's say the weight for the connector. Then you just the activation of the neuron is some function applied to the sum of all the vectors that come to this neuron, and then this activation function of the numbers, and you get the output. The main idea here is to find the values of the weights. The values are unknown. The system is learned. The system has been trained once all the weights has been established and has been established sufficiently good. Let's take a look. At the beginning, you randomly initialize weights with a very small, close to zero, some numbers. What you do, you take the first input values for the houses, okay? Area is 100 meters, 2 bedrooms, whatever, the age is 25 years, okay? You give these values and some random numbers here. To put it through in this black box. Let's say it's a black box. Doesn't matter which activation functions phi we have here. Doesn't matter. We put it inside this black box, and we get the real. We get them the output value. Okay, we get the output value. Why it's used for real value? Then what the algorithm is doing? It's just comparing. It's just comparing the output value to the real value. Okay, you have the output value, you have the real value. You need to compare them somehow, and so you'd use the cost function, the function of evaluate the how far is my output value from the real value. Okay, from the real price, and just compare them. And there are plenty of cost functions. This is just the only one example. So you calculate this cost function. It's quite high. The thing is, you want your output value be as close as possible to the real value. So what you're doing is actually trying to minimize your cost function, trying to minimize your error. You backpropagate means you turn your error back to your weights, and you change your weights, you adjust your weights, you change them, and you come and you repeat the process, and you calculate the output value, you compare it with the real value, you calculate the cost function changes, and you backpropagate from right to left the error. You backpropagate the error, the error is processing here, and the power of the neural network is that this process of updating the weights, it's actually according to how much each neuron responsible for the error. So this much, the weights are updated that are responsible for these neurons. Here we have only one neuron, okay? But normally we have this kind of line of neurons, okay? So, and the thing is that we know which neuron is responsible for which weights, and this is a kind of the very smart way of adjusting these weights. Basically, the idea is we repeat this process of calculating the error and again and again and again. And so once we see that the value of the error is very small, once we are close enough to of our output value to the real value, we finish the process. Okay, we finish the process for this input, for this particular house. But imagine we have a lot of houses. That was only for one particular house. But imagine for all houses in Barcelona of houses. And for each of these houses, we need to do the same process. The important thing here is the connectors, the weights. They are the same for all houses because we want our system to work equally good for all of these houses, and moreover for new houses in the Barcelona. Okay, so once we see this, the idea is, how do we do that? How can we adjust the error be equally small for all our data sets? We can randomly change the weights. Okay, I mean, I can go here and said, okay, my weight is 1, 2, 3, 4, 5, let's say. Then the error is very big. I come back, so change my weights. Okay, 5, 7, 8, 10, and this process, and it's endless because can't you imagine? Can you imagine how many possibilities do you have with these weights? I mean, you have a lot of connectors in your data set. So in this very, very small neural network, you have 16 weights. And if you want to try the 1,000 possibilities, so the best supercomputer will take you all the life. I mean, 10 in the power of 23 years to compute that. So what we are doing actually, for such a bigger data set, what we're doing, we basically calculating in the smarter way this adjustment. We're doing the smarter way. It calls the gradient descent. And this is a strategy of looking for the slope of the slope of the cost function, and somehow go to the direction of the minimum of cost function. We go something. We do not jumping and looking for the arbitrary values. We go to the minimum. And yes, this is the kind of deep learning structure. And what I wanted to say is that I'm speaking about the cursing of dimensionality and so on, and the process and the computer's capacities. But now the new cutting edge technology probably of computation is distributed computing. And distributed computing is that probably the new era of computing. That's when we are all participating in computing something. So our laptops and moreover our PlayStations participating in this network of computation. So a part of your memory of your own computer can be included in the network and can calculate something important for words. Let's say for folding for home, it's for example, it's a project that's currently simulating the dynamics of proteins and the proteins of coronavirus, for example. And now they have so many users distributed all over the world that they overperformed the capacities of 500 supercomputers altogether. They are doing this on the, I mean, extremely high capacity. So flops, it's a float operation per second. They do an incredible amount of operations per second. But the interesting thing, and I want to finish with that, is that what are they doing? They basically modeling the structure and the process of protein folding and the movements of protein, and they just modeling that because they somehow they can know they can. It's not a prediction. I mean, it's just modeling the protein or the molecule in some moment of time, its structure. The thing is, if the capacities of computer will grow, and if the number of users in this distributed computing will grow, then computers in the world will be able, in very near future, to modeling the life of coronavirus. Okay, so basically we will know what will be the structure of this virus in some points of future. And then we can do this for the bigger project, for the bigger objects. And then probably, if it's not very known, but probably we will arrive till the moment that this modeling can be done for the human size objects, and we can model the structure of our atoms, the structure of our bodies in some time, and we can compute it faster than it time goes, so we can somehow predict ourselves in future. This is the end for today. I have more information. I wanted to explain you about the natural language processing. It's actually the part which I'm having here. It's also can be done with the neural network, with the neural networks, with the machine learning. But anyway, that's a kind of another story. So probably, I can leave you the links that you can read, or probably if you have the question, I can briefly explain you now. But anyway, what I wanted, and that was the goal of my presentation, is that I wanted to understand that the main difference between deep learning and machine learning and another algorithms and another programming languages and other programming paradigms is that basically the algorithm learns by itself and adjusts and corrects itself. The more data he has, the more correct will be the adjustment, and the better will be his output and his or its performance. That's all. And I don't know the questions. Sorry for the delay. I mean, I'm really sorry.
It's okay. It's okay, Dr. Tetiana. Thank you very much. Let's open now a short space, 10 minutes, for questions and answers. If you want to ask something to Dr. Tetiana, you can type your question in the chat box, and we're monitoring that. So while we wait for someone to type, let me thank you again for this very complete overview on artificial intelligence and machine learning and deep learning. And I hope you will explain in the coming months. We will have another lecture about natural language processing, which is a very important topic too. Okay, so anyone wants to ask any question?
That's just, it's impossible to cover everything in 1 hour.
Yeah.
That's too much, especially a natural language processing. It's kind of very specific part of artificial intelligence. First of all, it has to be explained how we prepare text to be processed by the machine. We don't give them, as I said, we give to the machine the numbers, and how we convert the words to the numbers. This is quite an interesting question that can be, and the question that has been overthinking by a lot of researchers, and now we have amazing answers and amazing achievements in this direction, and also you can enter, and I really recommend you to check the GPT-2, the model, this generation of the text that I said. I've already said that I have one of my colleagues at my work, and he said to me, can you check my TFG project, the Treball Final de Grau? And I said, yeah, I mean, I don't want to, but okay, I will. So I checked the introduction, and there was a nicely written introduction about the artificial intelligence and natural language processing and so on. And he said to me, Tanya, but you know what? This is the work about the NLP algorithm written by NLP algorithm. So all his Treball Final de Grau has been written by the algorithm mentioned in this work. Wow. And this is amazing. I mean, this is really amazing. I will not say the name of this student in order not to.
So let me ask you 2 questions in these just 7 last minutes. The first one is, what are we to expect in the next years that you think is going to reach the big public and it's going to be somehow impacting about AI achievements? That's the first question. And the second question, as a researcher, which challenge would you like to tackle as soon as possible? Because now it's kind of difficult or blocking advancement in artificial intelligence.
That's a difficult question. That's definitely a difficult question, and both of them. And I suppose it's a topic of the discussion. It's not the topic of my opinion, because there are plenty of aspects here playing important role. But I suppose that now very important is the safety, okay, and also these kind of the policy how do we use the artificial intelligence, and the policy of using this, let's say, the red bottom. I don't know how to explain this. The notion of the red bottom is when you press the red bottom to say the algorithm to don't do that, stop to do that. So this question, it's kind of, I suppose we will arrive to this very, very soon. And the kind of which areas we can artificial intelligence to enter and which areas we have to block? This is kind of complicated question. And the challenges. There are short-term challenges and long-term challenges. I suppose for me personally, we need in the short term we need to try ourselves to focus on the medical problems, the problems that can gives us as much that can help us the real problem, especially due to the corona, especially for the pandemic and so on. But the long-term challenges, I mean, that's complicated to say. That's complicated to say that. I mean, we are living in the age in which every day we met the giant creature, the giant algorithm that are changing our life, changing our manner to treat the information that we get, to make the decisions, to I mean, they change the world simply, and we need to react.
Okay, we have still 4 minutes, and we have one question by Beatriz Vázquez, and she asked, how do you think artificial intelligence could be used in education with the students? Do you think it'd be positive for the learning process, or it could be negative if AI takes an important role in education?
Okay, it has to be used in the education with the student. The same as now we do the mathematics. That's the basic knowledge that student that finish its education has to have this basic knowledge in order to be able to continue his work or his studies or whatever. The same, we need to provide this basic knowledge of artificial intelligence and of this usage of our personal data. And I suppose it has to be introduced to the standard studying process, how it has to be used, and is it positive or negative? That's a question. That's what I said. It's very easy now to write the essay about any topic because you just enter to the website, which is open, and you just tap the beginning of the sentence, and the algorithm that know much better than you the topic, because it's been reading all the Wikipedia and all the books that you didn't, definitely. So he did quite well for you, and you don't need to do any effort. How do you prevent that? So you need to have this knowledge and this aware of all of these possibilities for students, and so you need to use it as an advantage for the. I mean, you need to introduce these methods in order to collaborate with them, not to try to close ourselves and to not allow students to use them, because you can't, and no one can.
Okay. We have one last question, maybe in 2 minutes. You can just give us very short ideas about that. It's Juanjo Martin says, what do you think of Elon Musk's OpenAI Foundation? Are these governance bodies justified? Can you elaborate on the topic?
Okay. So I don't know if you of AI Foundation. That's the Elon Musk project. So Elon Musk and Allen Research Institute, and also plenty of other researchers all over the world. They formed this community. They have a lot of data and a lot of computational capacities. Okay. And they are working on producing these cutting-edge models, cutting-edge algorithms, and they make them completely open for everyone, open access for everyone, for the code also. So the code has no, it's just in the short introduction. The code has no the authorship. Okay, the code it's open and it's done for everyone to be able to participate and make the models better and better. So what I'm thinking, that's a great idea. I use open AI algorithms. I use the transformers that's the platform that offers you a lot of algorithms that you can just take them and use them. That's kind of a monopoly. That's kind of a monopoly of AI processes, because even you have access to the code, you can't. I mean, me personally, or everyone can't replicate the models because it's just simply not enough capacities of your own laptop or on your own computer centers, and you have not enough money for that. They have a kind of monopoly for that, for their products, let's say, and basically by now it's useful because you get the very good performance for your particular projects, for your particular initiatives. You can get the very good performance using this biggest creature made for these bigger companies with no cost. But the term effect of that can be, I mean, it's concerning. It's definitely concerning. And they've already closed the access for some algorithms. That's for sure, for GPT-3, for example, because of awareness of its bad usage.
It can be dangerous, right? So we have to finish it here. Thank you very much for your lecture. Well, there is one last minute question that you may answer in 10 seconds, which is, which programming language would you recommend for neural networks?
Definitely Python. Definitely Python.
Okay.
And yes, you
can
try out Python.
Okay, we have to leave it here. We have more questions incoming, but we have reached the end. Thank you very much. And let me just announce something before everyone goes. It's that in 2 weeks, on March 17th, 2:30 p.m., we're having another lecture by Xavier Marcet. He's going to explain us the impact of artificial intelligence in the business world, specifically in the business world, how it's going to transform the business world. So I see you all, if you want, in 2 weeks for this next lecture. And thank you, Dr. Tetiana.
Thank you.
Bye-bye.